Smart contracts are a crucial element for DeFi products to function. So, what exactly are smart contracts? Let's start with a brief history of the concept behind them. Lawyer and computer scientist Nick Szabo first described the idea of smart contracts in the 1990s. A smart contract is a tool that formalizes and secures computer networks by combining protocols with user interfaces. Potential uses were envisioned in fields involving contractual agreements, such as credit systems and content rights management. But it was only after the launch of the Ethereum network in 2015 that smart contracts gained wider adoption. In the world of cryptocurrencies, a smart contract refers to self-executing computer programs that run on the blockchain when predetermined conditions are met. The conditions are predefined by computer code, which is replicated and executed by all network nodes. Blockchain smart contracts allow for the creation of trustless protocols. This means that two parties can make commitments via blockchain without having to trust each other. They can be sure that the contract won't be executed if the conditions aren't fulfilled. Each blockchain may present a different method of implementing smart contracts. In this module, we will focus on the smart contracts that run on the Ethereum network. So, how does a smart contract work specifically? Because a smart contract executes a particular task when certain conditions are met, it often follows the if-then computer programming statement. A smart contract contains lines of computer codes that say, if X condition is met, then Y will be executed. Please note that despite the terminology, smart contracts are not legal contracts. They're just a piece of computer code running on the blockchain. As a matter of fact, smart contracts exist so that legal contracts don't have to be made. There's no need to get a lawyer, a court, or a government to enforce contract law if everything that needs to happen in an agreement happens automatically when the predefined conditions are met. As the saying goes, in code we trust. Smart contracts have unique characteristics. Ethereum smart contracts often are distributed, meaning that smart contracts are replicated and distributed in all nodes of the Ethereum network. Ethereum smart contracts are also deterministic. They only perform the actions they were designed to when the requirements are met. The outcome will always be the same. Ethereum smart contracts are immutable, meaning the execution is automated, and the smart contracts can't be changed after deployment. They can only be deleted if a particular function was previously implemented. Smart contracts are also transparent, with their code visible for everyone to see. Smart contracts can be used for various use cases, including DeFi, voting systems, and games. As we explained in the previous modules, DeFi transactions are completed via smart contracts. Smart contracts can also be deployed with other blockchain solutions in the healthcare, supply chain, and governance sectors. Of course, smart contracts have their limitations. Because people write the computer code in smart contracts, they are subject to human errors. The immutability of smart contracts also makes fixing any mistakes very difficult. For example, millions of dollars worth of Ether was stolen when a decentralized autonomous organization called the DAO was hacked in 2016. The hackers took advantage of flaws in its smart contract code. Since the smart contract was immutable, it was challenging for developers to fix the code, and it was impossible to reverse the fraudulent transaction on the blockchain. This eventually led to a hard fork, giving birth to two separate Ethereum chains. Let's move on to DApps. As you probably guessed by now, DApps are applications that run on blockchain networks. DApps can perform functions that are similar to applications on your phone or computer, but the back-end system is different. DApps rely on smart contracts on a distributed network to function, unlike standard mobile apps that rely on centralized systems. Similar to smart contracts, DApps are open source, meaning anyone can verify, use, copy, and modify the source code. All information of DApps is cryptographically secured and stored on a public, decentralized blockchain, maintained by a network of nodes. Another characteristic of DApps is that they can be accessed with a cryptographic token. Today, DApps generally refer to all applications with smart contract functionalities running on blockchain networks. You can think of smart contracts as a core component of DApps, while DApps are the product that provide a complete application experience to users. There is a great variety of dApps with different use cases, such as gaming, social media, entertainment, and of course, DeFi. As of mid-2022, most dApps exist on the Ethereum network, but developers are building dApps on many other blockchains. As of mid-2022, there are a large number of dApps, and the sector is still in the early stages of development. Despite dApps facing scalability and code modification difficulties, particularly on the Ethereum network, the industry is expected to grow in applications and active uses as decentralization becomes widely adopted.